Hello, we are live. Okay, it's Doug, and we're going to do more decimals. But first, the preamble. Okay, this is a Barcelona jersey. I think I might be wearing a Barcelona jersey 2 weeks in a row, but I have quite a few Barcelona jerseys, so that's going to happen sometimes. The weather. It's snowing. It snowed again this afternoon. I think it's going to be one of those winters where it just starts being winter several weeks early, and it doesn't take the hint that we should at least get a break where it becomes nice out again for a little while and then becomes winter again. I don't know if I can count on that. And I have not caught up on all of the putting away of things that I have to do in the autumn. In fact, this past weekend I did almost nothing. I was busy doing my crafts. I was making gingerbread men out of wood. Excuse me, that's important. And over here there's a dog and she wants attention, so I'm actually going to move the camera, which is a phone. I'm going to move the phone, I'm going to show you the dog, but that means I'm going to have to get it set up again afterwards. So let's take care of a few things at once. We will show Mocha to the students. There she is. That's right, she's doing a little stretchy thing where she thinks she's a cat. She's acting cute. She knows it's actually supper time. But what I'm going to do now is I'm going to banish her upstairs. And I'll bring you with me while I do that. Sorry about the shaky hands. It's not easy to do this. Okay, so I'm at the door. And now, okay, say goodbye, Mocha. Yeah, that's right. Wave goodbye. That's right. Okay, off you go. And I may as well get my can of fizzy water from the fridge. Where's some fizzy water? I'll take this one. It's the first one I saw. And yes, there is a giant snowman guarding my fridge. Don't ask why. So let's get into the math. Let's see if I can get this back onto the tripod, which is actually not a tripod. It's a music stand. That's my hint for all of you people who want to make videos. The best tripod is a music stand. And we're ready to get into the math. Okay, so what I have here are a couple of little math problems. I'll make sure they show. I think it's set up pretty good though. So I'm going to do those first, and that's a review. We did adding and subtracting of decimals last week. I have a little broken piece of chalk here. I'm going to use it to answer these two problems so that I don't waste it. So we're just reviewing this. So I have the subtraction first, then the addition second. That's not normally the order, but I know that the students already know how to do both, so I don't have to put the additions first. That's the luxury of teaching people who already know everything. Okay, 3.8 minus 1.6. Notice how these are written in a line, not one above the other, the way we like to show our steps when we do a subtraction. But we can just take any subtraction that's listed like this and write it the other way. So I'm going to do that. 3.8 minus 1.6. I think I can get this chalk to behave. How does that look? It looks pretty good. Okay, need that line. And of course I lined the numbers up so the decimals are right above and below each other. And right away, before I forget, I'm going to put a decimal down here right below the other ones. And then it's a subtraction. We know how to do a subtraction. 8 minus 6 is equal to 2. 3 minus 1 is equal to 2. We have our answer. We didn't even have to do any borrowing because this was a bit of an easy one. And then, of course, we can verify our answer by adding the 2.2 and the 1.6 and seeing if I get 3.8. Let's do it. 2.2 plus 1.6. Put the line, put a decimal right below the others. 2 plus 6 is 8, of course. 2 plus 1 is 3, of course. And we got 3.8. We knew that would happen. How about 4.6 plus 7.8? This is just a quick review of an addition. 4.6 plus 7.8. Okay, I need a decimal right here. 6 plus 8 equals 14. We have to carry. We put a 4 and we carry the 1. 4 plus 7 is 11 plus the 1 I carried is 12. We're able to write all of the 12 here because we got to the end. And we have 12.4 as our answer. Easy peasy, pudding and pie, but we knew it would be easy because it's just a review of the last lesson. Now let's get into some of this lesson. And are we going to get really crazy with our next example? I don't think so, because that's not my style. I'm just going to do a bigger subtraction, with and without decimals. And we're going to think about what that means. I will erase. Okay, I'm still going to try and use this piece of chalk a little bit. How about 357, that's right bigger, Doug, 357 minus 180. No decimals in this one, so that's really a review, but the numbers are bigger. We have 3 digits numbers. 7 minus 0 is equal to 7. 5 minus 8 we can't do, we have to borrow, so it's going to be 15 minus 8, but this 3 will become a 2. 15 minus 8 is 7, and then now we're doing 2 minus 1 because we borrowed from that 3. 2 minus 1 is equal to 1. We have our answer as 177. But what if we had this problem instead? I'll write it down here because I'm going to use this space to answer it. If instead we had 3.57 minus 1.8. Okay, now it's a decimal problem. And we have 3 digits in one of the numbers. Let's line it up. 3.57 minus 1.8. Well, to line up my decimals, I have to put the 1 here and the 8 there, and there's nothing there. So what do? I know you know the answer. We realize that we need to put a 0 here. We can show it or we can not show it. I think we can successfully get this answer either way. I like to show it. I put my line. I know I need a decimal right below the other ones because with addition and subtraction, when you are lining up to do it like this, you need to make sure that the decimals are lined up. Otherwise, there will be a problem. Now, we have turned it into a decimal problem. It is a little bit bigger than the ones I was doing last time, but it's still not going to be a big problem. And when we look at the numbers, we realize, well, these are the same numbers that I had in this problem. And it's useful to do that. 7 minus 0 equals 7. 5 minus 8, I have to borrow. So I'm going to borrow from this 3, which is going to turn into a 1. And the 1 I borrowed from the 3 turns into a 10, turns that 5 into a 15. 15 minus 8 I can do, and that gives me 7. And then we're doing 2 minus 1, so we have 1. And the answer is 1.77. It's really the same problem, which was the point. The point, get it? It's the same problem with or without the decimals. You just have some extra things to do when the decimals are involved. And it makes the answer quite a different size, because 357 minus 180 gives a great big answer like 177, but 3.57 minus 1.8 gives a little tiny answer like 1.77. So this idea of knowing which numbers are bigger and which ones are smaller is important, otherwise we would be confused right now. But I don't think anyone's confused because we know how to do this. And then of course I can verify by adding 1.77 to 1.8. By adding my answer 1.77 to 1.8, I should get 3.57 as the answer. And you know what? I think I'm going to do that. I'm going to verify that. So I'll do it here. Reminding us that whenever we do an addition, we can verify it if we know how to do the subtraction. Whenever we do a subtraction, we can verify it if we know how to do the addition. And that gives us a lot of power. Okay, so I am saying 1.77 plus 1.8. Lining up the decimals, at this point I think I'll erase this question because it's going to get in the way, maybe a bit. And oh boy, there's hardly any chalk here left. Okay, so when I'm adding these, I'm going to put a 0 there. And again, do I have to? Maybe I won't this time. I'm going to say, no, I'm not going to show a 0. I just know there's a 0 there because I can see how big these numbers are. So I know I'm doing 7 minus 0 equals 7. I'm still able to do it whether I show the 0 or not. My preference is to show the 0. And then 7, I said minus. 7 plus 0 is equal to 7. Fortunately, I didn't make a mistake. 7 plus 0 is equal to 7. 7 plus 8 is equal to 15. I have to write the 5. and carry the 1, and I did it again. I forgot to put my decimal. But of course the decimal I should have put right away and below the other decimals. Make them all look nice. Okay, so 7 plus 8 is 15. I write the 5 and I'm carrying the 1. So now I'm doing 1 plus 1 is equal to 2, plus the 1 I carried is equal to 3. And I have 3.57 as my answer, and we knew that would happen because this is a verification. Okay, let's move on to doing a couple of slightly different looking ones. Really, the only thing that's happened this week that's really new is that I've started incorporating some 3-digit numbers into this type of question. But that has to happen eventually. So there we are. Now I'm back to my loaded chalk dispenser thing, and I'm going to open my fizzy water, and I'm checking the time. I always like to check the time, see how I'm doing. In my lesson plan, I put little numbers with circles around them, 5 minutes here, 10 minutes there, trying to figure out how long it's going to take to do things, and that helps keep me on track. It's the root beer flavored fizzy water again. Okay, what's my next question? Not a huge leap upwards. 6.82 minus 5. Okay, so what's different? This isn't a decimal. This is just a whole number, but this is a decimal. We're mixing decimals and whole numbers. What happens? Okay, in this case, I am subtracting the whole number from the decimal, but of course it could go the other way around. Maybe we'll have an example where that happens sometime soon. But 6.82 minus 5, and I wrote it in a line. I prefer to write it with one number above the other. I'm going to subtraction. I'm going to even put this line here, but I have to put 5, and of course I have to know where to put the 5 because this doesn't have a decimal. But when a whole number doesn't have a decimal, we know that the decimal goes right after the whole number. This is 5.0 if we really want. So the decimal is to the right of the 5. I put my decimal right below the other one, and that means the 5 is going to go here. And I can subtract, and I can show these zeros, or I can not show them, but as you know, I prefer to show them, so I'm going to put a couple of zeros there, and suddenly it turns into a kind of an easy subtraction question. Because 2 minus 0 is easy, doesn't involve any borrowing. It gives me 2. 8 minus 0 is easy, doesn't involve any borrowing, and it gives me an 8. The decimal should have already been written. Oh, why do I always forget until I'm halfway through doing it? Okay, the decimal is written below the other ones. 6 minus 5 is equal to 1. We have our answer. And of course, there's a kind of a shortcut with this one because it is kind of an easy one, which is that a lot of us won't write it like this and show our steps like this, because what we will be doing, and we're doing some of this in our heads, is saying, oh, 6.82 minus 5, I just have to subtract the 5 from the 6, because there's no decimals over here to worry about subtracting from the 8 and the 2. So the 6 minus 5 is going to give me a 1, and then of course, since I didn't subtract anything after the decimal, the 0.82 is still going to be there. Well, that's a way of thinking our way through the problem and getting the same answer, and it is the correct answer. But when things get confusing, you don't want to try to do things in your head, and it is really good to have these skills to fall back on. My next example, ooh, I didn't even write down the answer, so I'm taking a risk. I'm going to erase. And poor Mocha. It's supper time, and that's why she was all excited and she needed to go upstairs. But I didn't actually tell anyone up there to give her supper, so she's probably waiting for me, and she probably will have to wait until I go up there before she can eat. The life of a dog doesn't know how to use a can opener or even open the pantry door or rip open a bag of dog food. She just doesn't know how to do those things. She has to depend on me for everything. It's a good thing she's so cute. Okay, 8. There's a whole number, minus 3.205. Okay, now he's going a little crazy. He has a decimal with 4 digits in it. But I think that we can do this. But, oh, whoa, but we're subtracting all this from just this little 8. What do we do? Again, the right thing to do is to show the subtraction lined up with the numbers one above the other. It's going to be 8 minus, now, where do I put my decimal? That, if it has a decimal, has to be right here. So I'm putting the decimal because that helps me to line it up with the other number. Therefore, the 3 is going to go here. Put my decimal, put 2, 0, and 5. Put a line, put a minus sign, put a decimal. Remember this time right away, put a decimal below the other ones. Now what do? I really want to show the zeros here. 8 means 8.000 if I want. I can show as many zeros as I want, but I need 3 of them. And I really want to see them because I find this very confusing to try to do without seeing those zeros. But I guess it's up to the choice of the individual. Now there's going to be some borrowing, so I get to do my review of borrowing at the same time with this example. There will be quite a bit of borrowing. And that's what happens when you have really small numbers like zeros over here and you're subtracting bigger numbers from them. You have to borrow. Okay, so 0 minus 5 I can't do. So I'm going to borrow. So that means I have to turn that into a 10 by borrowing a 1 from this column. But oh boy, that's a little crazy because all I see is zeros over here. So let's not worry about it. Let's say, okay, so I'm turning this into a 10 by borrowing. 10 minus 5 is equal to 5. I'm able to do that part. Then, what did I borrow it from? I have to have borrowed it from a 10 because I have to borrow in order to get this number big enough to do anything with. So I am going to turn that into a 10, and then because I borrowed from it, it's now a 9. Woo! Okay, have I made this problem too difficult for myself to do? I don't think so, but I don't know if I'm explaining it as clearly as I wish I was. 9 minus 0 is equal to 9. We're going to find out if this all works at the end when I do my verification. Okay, so how did I get that 9 though? I got it by borrowing. I borrowed it from here. So that means this was also borrowed. Oh boy. So this 8 turns into a 7. And in doing that, I'm able to turn this one into a 10. But then, of course, I borrowed one from it, so it turns into a 9. Whew, I think it's finally looking a little bit organized though. Okay, let's think my way through this. I had an 8, but I'm borrowing from it, so it turns into a 7. When I do that, I get a 10 in the next column. Since that 10 added to 0 is still a 10, I would have a 10 to subtract something with from here, except I needed to borrow from it to do this one. So that 10 turned into a 9. It makes sense. I think I've got it. Okay, so now I'm finally going to do this subtraction. 9 minus 2 is equal to 7. And I only have a 7 here now. 7 minus 3 is equal to 4. Did I do it correctly? Do I have room to show my verification over here? I think I do. So what I'm going to do is I'm going to try adding 4.795 to 3.205 and make sure that I get 8. Let's see. 4.795 plus 3.205. And I guess we're going to be practicing our carrying as well. 5 plus, oh, put the decimal. I'm getting better at remembering this. 5 plus 5 is equal to 10. I put a 0 and I carry a 1. 9 plus 0 is 9, plus the one I carried is 10. I put a 0 and I carry a 1. 7 plus 2 is 9, plus the one I carried is 10. I put a 0 and I carry a 1. 4 plus 3 is 7, plus 1 is 8. It worked. I got 8.000, which is equal to 8. I did it. Wow. I tried to make it really hard, but it still wasn't really hard because I know how to do it, because I'm using all these skills that I already knew. The decimals are new to us, but we knew a lot of these skills, all the other skills we're using to do this, the things like the borrowing and the carrying, we already knew how to do that. The only thing that's new is the decimals, and all we have to worry about is to make sure we remember it's adding and subtracting. We have to put the decimals so that they're lined up. Then it'll work. Okay, that was fun. Now, another one. And it's going to be not really a word problem, but it's going to be a money problem. I like the money problems because sometimes the numbers get much bigger and they get to be more numbers when you have money problems, and yet they don't seem really, really scary hard because money often has a lot of zeros in it, and zeros aren't really that hard to deal with when we do the math. It helps to make the students feel more confident. I like that. So I'm going to buy something in a store, And it's similar to what I've done before. I'm going to buy several things at once, and I know how much money I have to spend, and I want to see how much change I'm going to get. So what I like about this problem is that it combines the adding skills with the subtracting skills, and we actually kind of have a choice as to how we do the problem, how we do our steps. So what I'm going to do is list what we're buying first. So we're going to buy an apple, and that costs 80 cents. Excuse me. Okay. I could feel that coming for the past couple of minutes. Okay, and I'm also going to buy a pineapple. Better write a little smaller, pineapple. And that costs more than an apple because it's bigger. It's going to cost $2.65. And I'm going to buy a cake. Now, why would I go to the store with a list that includes an apple, a pineapple, and a cake? A fruit, another fruit, and a cake. I don't know. Doesn't matter. How much does the cake cost? That's what matters. The cake costs $8.59. So we're going to add these numbers together to figure out how much I spent. But we also have to know that I went there with $15, and I want to know, the question actually is asking, how much is my change? So adding together these numbers is useful, but it's not answering the question. Getting a total and subtracting it from 15 is going to answer the question. Do we want to try to line up numbers of decimals, putting the decimals above and below, and do addition and subtraction at the same time? I don't think so. So I can think of only two ways of doing this problem. One of them is a lot less trouble than the other. What we could do is we could take $15 and we could subtract the cost of the apple and see how much we have left. And then we take how much we have left and we could subtract the cost of the pineapple and see how much we have left. And then we take how much we have left and we subtract the cost of the cake and see how much we have left. But is that the way we do it when we're buying something in a store? Is that the way it's done? No. What we do is, because it's more logical, because it's less steps, because it's going to take less time for us and the cashier when we're buying this stuff, we're going to add these together and get a total. And then we'll only subtract once. We'll subtract the total of the costs of all three from the $15 to see how much the change is. So it becomes a two-step problem. I don't want to try to do this in one step, but I also don't want to do it in 4 steps. Okay, adding these together, well, it's kind of lined up pretty good already, so I'm just going to put a line and a little plus symbol there, and I'm going to put a decimal right below the other ones. I'm ready. I'm adding 3 numbers, and they're all 3-digit numbers, although this one has a couple of zeros in it. But isn't it interesting and convenient how money tells us to put the zeros in the right places and makes the number easier to deal with when we do our math. Money is convenient in that way. We get used to showing zeros in the right places when we have money. Okay, we're adding these together. 0 plus 5 plus 9. 5 plus 9 is 14. I'm putting a 4. And I'm carrying a 1. 8 plus 6 is 14. Plus another 5 is 19. Plus the one I carried is 20. Oh, I'm putting a 0 here and I'm carrying a 2. In all the examples I was doing last time, I never carried a 2. Why? Can you guess why? Let's think about it. But this time I'm carrying a 2. 8 plus 2 is 10, plus 0 is still 10, plus 2 is 12. I spent $12.04. I like putting my unit of measure, even though it's not the final answer to this question, because I still have to figure out how much change I'm going to have after I go and pay with $15. So $15 minus $12.04. Line up the decimals. Put a decimal for the answer right away, lined up with the other ones. Have to do some borrowing. 10 minus 4 is 6. Well, it's not 10, it's a 0. I have to show that I'm borrowing. Oh, I'm doing that double borrowing thing again. So I'm going to start from this end and show it. That 5 is going to turn into a 4, which turns this 0 into a 10. But right away, I'm going to borrow 1 from that 10, and it turns it into a 9. The one I'm borrowing is turning this 0 into a 10. Now I can do it. 10 minus 4 is 6. 9 minus 0 is 9. And then 4 minus 2 is 2, and 1 minus 1 is 0, so I have my answer. I don't have to write the 0. I have $2.96 in change, and that makes sense. And I can verify. $12.04 plus $2.96. I can add them together and make sure that they add up to $15. But I'm feeling pretty confident right now. Why is it that I was carrying a 2? Remember I said we were going to think about that? Because why did I never have to carry anything except a 1 in all of the previous examples I had done? Because I kept on adding 2 numbers. I wasn't adding 3 numbers, or I didn't do it very often. So I add 3 numbers here, and I had the opportunity to get this thing happening that happened in the middle, and it's just chance sometimes whether this happens or not. But 8 plus 6 plus 5 adds up to 19. I almost got to 20, but then because I had carried 1, it did hit 20, and that's why I'm carrying a 2. That's cool. So if you add more numbers, then the chances of carrying other things besides 1s is going to happen more often. Kind of interesting. Okay, where am I now on this lesson plan? I've gotten to the end of this page, but the second page is on the other side. And let me see how I'm going for time. Ooh, almost right on. I'm only 1 minute away from my projected time. And that minute, I think, had something to do with all sorts of distractions that involve soccer jerseys and the weather and cute dogs and fizzy water and giant snowmen guarding fridges. Okay, why would that be happening? I'll tell you the reason why. The reason has the name Bunny. That's the reason why. Okay, so now what we're going to do for our next few examples, we're going to multiply. We have done lots of adding and subtracting of decimals. Now we're going to start doing some multiplication of decimals. So erase, erase, erase. I think I might be able to put the clipboard down now and just leave it over there. And erasing is good, but taking a sip of the fizzy water is also good, especially if that sneeze and cough is coming from the chalk dust. Okay, let's get into some multiplication, but of course we want to start small. Multiplying decimals. I have 3.2 multiplied by 40. So we're starting fairly small. One of these has a decimal, the other one is a whole number. That is a pretty big whole number, but it is a multiple of 10. It's 40, and you know, 10s are kind of easier to deal with. Now, how am I going to do this? There's more than one way of doing this. And one way of doing it is to multiply 32 by 40 and then just correct it later. And that's what we're going to do for now. So can I do 32 times 40 in my head though? A lot of people would want to be grabbing at a calculator right now, but what I'm thinking is I could do 32 times 10. Now how am I going to write this? Yes, I'm going to write it like this. Or should I put the equal sign? I'm not going to show the equal sign there. I want to be well organized here. What I'm going to do is I'm going to multiply 32 times 40 instead. And then I'm going to adjust my answer to figure out where the decimal goes. Now, how do I do this? 10 times 32 is easy. Multiplying things by 10 is easy. 10 times 32 is 320. But there are 4 10s in 40. So I have to figure out, okay, 10 times 32 is 320 and then multiply that by 4. 320 times 2 would be 640. So times 4 would be like 640 times 2. 600 times 2 is 1200. 40 times 2 is 80. So 1280. It's going to give me 1280. Now this is fun to do, but if we're not really good at it and we're going to get wrong answers, it's a good idea to grab the calculator and check. I'm not going to check. I'm feeling quite confident that it's 1280. Now, but the answer to this is not 1280. And this is where ballparking comes in handy. To get an idea of how big an answer I should be getting, how big an answer I should be expecting, I think, okay, well, 3.2 is awfully close to 3. And then 40 is already a nice round number. So what's 3 times 40? It's 120. It's not 1,220. It's not 1,200, it's 120. So that means I expect this answer to be close to 120. And the way to do that is to realize that since there was a decimal here, and one of these digits was after the decimal, I'll show it like that, that means that one of the digits in my answer should be after the decimal. And that's an interesting concept with multiplication of decimals that we have to get used to. And it's quite different from what we've been doing with the adding and subtracting. But this is actually correct. Now, of course, when you have 128.0, you don't have to write the 0.0. You can say, oh, well, that's equal to 128, and it's true. It is the right answer. 3.2 times 40 is equal to 128. But now, I find it confusing to look at. So I don't know what to do. I'm going to erase it soon is what I'm going to do. But what I ended up doing, because I ended up installing the decimal, is I ended up giving the answer to the original question and not this other one that I had decided to do that didn't have decimals in it. So when you decide to multiply and not show the decimals so that you can see what your answer is going to look like, make sure that you remember that you took that decimal out, because you're going to have to go back in by the end. And that's kind of cool. That's a fun example. Let's do a couple more where we take this approach. And I don't want the numbers to be really crazy and big and scary yet, because we're just getting started with this. 0.5 times 0.25. Okay, 0.5 times 0.25. Well, what I can do is I can say, okay, if I didn't have the decimals, then this would be 5 times 25. And that one's a fairly easy one to do in my head. 5 times 25 is going to be 125. But that's the answer if you have these numbers without decimals. But we have these numbers that look the same, but they do have decimals. And what we need to do is figure out how many digits need to be after the decimal in our answer. And the way to do that is to count how many digits are after the decimal in total in the numbers in the question. And there are 3. So therefore, I want to put a decimal here so that there can be 3 digits to the right of it in my answer. And I think I've got the right answer. So this is interesting. We're seeing what's happening with multiplication, and a lot of it, like subtraction and addition, we can sort of do it without the decimals and see what our answer looks like, and we get all the right numbers in the right positions. And all that's left is to make sure the decimal ends up in the right position. That's sort of the same as with multiplication. That's sort of the same as addition and subtraction. But there are other ways in which it's not the same. And one way of showing that is I'm going to do the same question over again, but I'm going to line them up with the numbers lined up in the other way of showing all of these operations, but in this case, that other way of showing a multiplication. So I had 0.5 times 0.25. Wait, I'm lining this up with the decimals above and below each other the way I would if it was addition or subtraction, but it's not. So that's an important rule with addition and subtraction, is you line up the decimals. But with multiplication, that's not what you have to do. And in fact, I think it might end up making things really confusing if you try to do that. So what I'm doing instead is I am lining them up so that the last digit of one number is right below the last digit of the other number. So we don't line up the decimals when we multiply. This is a difference from multiplication from the addition and subtraction techniques that we learned. We're writing our line, I'm putting that multiplication symbol, and now another difference is I'm not putting the decimal underneath the line yet. I will do that last. What am I going to do? I'm going to sort of ignore the decimals and just multiply the numbers. So 5 times 5, that's what I would do first if this was a normal multiplication and you didn't have decimals there. 5 times 5 gives 25. So I have a 5 and I'm going to carry a 2. 5 times 2 is 10 plus the 2 I carried is 12. So I have to write it like this. It's working. It's the usual method that we always have done with multiplication. But now we have that extra step. We count how many digits are to the right of the decimal in the numbers in our question. And there are 3. So we need 1, 2, 3 digits to the right of the decimal in our answer. So 0.125 or 0.125 is the answer. It works. Slightly different, but it works. If this works, then all the multiplications of decimals will work. So let's do a few more and test this. Try it out. I'm going to make one up because my lesson plan doesn't have another one like this yet, but I don't want to move on to my next thing yet. So I'm going to make another one. I guess I'll just write it here. Let me see. And since I'm making it up, it means I don't know the answer. So I'm going out on a limb here. I'm taking a risk. How about 4.37 multiplied by just 0.86. Okay, some fairly large numbers. We're going to be doing some carrying. I need my line. Now, I did happen to put the decimals one above and below the other, but it's just because I'm following that other rule where the last digit in the numbers I had are lined up one below the other, and it just so happens that both of these numbers have 2 digits to the right of the decimal. So I'm lining it up in a way that works for multiplication, but it also looks like the way we used to line them up for addition and subtraction. Doing it for a different reason. Okay, let's erase this previous example, and let's flex our multiplication muscles in a decimal way. Well, what do we do when we multiply decimals? We have it set up, we ignore the decimals, and we find the answer to the multiplication, and then we'll count digits and put the decimal plate into its place in the answer at the end. So, first I'm doing 6 times 7. 6 times 7 is 42, so I write the 2 and I carry the 4. 6 times 3 is 18, plus the 4 I carried is 22. I write the 2 and I carry the 2. 6 times 4 is 24, plus the 2 I carried is 26, and I'm able to write the whole thing. That's the answer to the 6 times the 437. But now I have to do the 8 times the 437, and that's where we have an extra little thing to make sure that we do. That 8 isn't in the last position. There's a position to the right of it. So what I have to do is I have to put a 0 here. And then I do 8 times 437, and I write the answer all to the left of that 0. So that is a new thing that happens with multiplication that we don't do with the other operations. Okay, let's do this. 8 times 7. Now, I also have clutter that happens. I should have written the whole problem a little lower so that it didn't bump up into my title of decimals, because I have these numbers that I wrote in because of the carrying, but now I might have to do some more carrying. So I have to watch out that it's going to get cluttered, and I don't want to get lost and use the wrong number. So I have to be careful. It's just a matter of slowing down. 8 times 7 is 56. I'm going to write the 6, and I'm going to carry a 5, and I'm just putting it above that 4. I'm ignoring the 4 now. I'm going to use the 5. 8 times 3 is 24, plus the 5 is 29. So I'm putting a 9 here, and I'm carrying a 2. Now this one has happened to be 2 both times, but I'm ignoring one of them and I'm using the other one. 8 times 4 is 32, plus 2 is 34. I write the 4, and I'm able to write the 3. Whew. This is a bit of a big problem. Now I have to add these together to get my final answer, and I'm still not ready to put the decimal place into its position. But I did all of this carefully. I think I haven't made a mistake. I'm going to double check this one with the calculator when I get to the end. 2 plus 0 is equal to 2. 2 plus 6 is equal to 8. 6 plus 9 is equal to 15. So I'm writing a 5, and here I am doing a different type of carrying. That's carrying that 1. 2 plus 4 is 6, plus the 1 I carried is 7. And then here all I have is this 3, so I just bring down the 3. Finally, I can put in my decimal. And I have 1, 2, 3, 4 digits to the right of the decimals in total in the 2 numbers in the question. So I need 1, 2, 3, 4 digits to to the right of the decimal in my answer, and I have 3.7582. And now I'm going to try the ballparking thing. 4.37 it's a little bigger than 4, but I'll call that a 4. 0.86 is less than 1, but let's call it a 1. It's pretty close to 1. 4 times 1 is equal to 4. So my answer should be close to 4. And look at that. 3.7582, regardless of how many digits we have over here, 3 point something that would almost round up. Oh yeah, this is fairly close to 4. I feel a lot of confidence in this answer. I'm still going to get out my calculator and double check it though. And it really doesn't hurt to do this, especially while we're learning. 4.37 times 0.86, 3.7582. I did it. Okay. That's good. So that's a bit of a big one. A lot bigger than the previous two examples. Now, what else had we done in those previous two examples? We had tried multiplying the numbers while pretending the decimals weren't there. So I'm going to leave this here, and I'm going to write the problem again. 4.37 times 0.86. And let's just pretend it's 437 times 86. Now, I'm not going to go through this whole rigmarole. I'm just going to use the calculator. 437 times 86. Yep, 37,582. But we had 4 digits to the right of the decimals in the two numbers in the question, so we need 4 digits. The same answer. So anyway, it works. Let's get rid of the calculator and let's look at what's next on my list of things to cover. We're going to switch back to something easy. This is a little bit of a crazy one, I admit it. But if we use the techniques that we were learning with the simpler multiplications of decimals, we're able to do this. And most of it is stuff that we already knew because we already knew how to multiply numbers like this, but without the decimals. So we just have a couple of extra steps that we have to put in. But what other types of multiplication are there that are easier? Well, one of the things that's kind of fun with decimals is when you're multiplying a decimal by 10, or if you're dividing a decimal by 10. So let's play around with that. 3.6 times 10. Again, 36 times 10 would be 360. And then we could just count digits and move our decimal into the right place. So it would look like this. I'll say 36 times 10, which is 360. And then we would look over here and we see only 1 digit to the right of the decimals in total for these two numbers. So we would have 36. We have our answer. It's 36. So we have that technique and it works. But of course, there's sort of a shortcut here, which is, since we're multiplying by 10, the 3 and the 6 didn't change. There's still a 3 and a 6 in the answer. And that happens when you multiply things by 10. It also happens when you divide things by 10. So that gives us a type of question that's kind of easy. What we can do instead is we could say, well, 3.6 times 10, since I'm multiplying it by 10, I see 1 0 here. I'm going to end up moving my decimal 1 place to the right, and my answer is going to be 36. And this works. We can do this, but we can also do this. So let's try doing it with a few other multiples of 10. 3.6 times 100. We know the answer is going to have a 3 and a 6 in it because it's being multiplied by 100. All it is 1 with zeros, and when that happens, these numbers don't change. You still have a 3 and a 6. But we have to move the decimal 2 places to the right because there's 2 zeros in 100. So moving the decimal 2 places to the right, well, I can't even show that unless I put another 0 here. So the decimal moves, if you imagine it was here at the beginning, it moves 2 places to the right, and 3.6 times 100 is 360. There. Okay, so it works. 3.6 times 1,000. It's going to have a 3 and a 6. I need to take that decimal and I need to move it 3 spaces to the right, which is hard to show unless I put some zeros. Oh, I put the decimal in the wrong place there. I was confusing myself. Okay, so I write my 3.6, but I put 2 extra zeros because I need to move that decimal 3 places to the right. 1, 2, 3 places to the right. The answer is 3,600. And I think the students already knew that that was going to be the answer because these are easy for a reason. We're able to do a bit of a shortcut whenever we're multiplying a decimal by 10 or 100 or 1,000. And we're doing the same sort of shortcut whenever we multiply a decimal, whenever we divide a decimal by a 10 or 100 or 1,000. I'm not going to get very much into division of decimals in this week's lesson, but those ones I'll get into because they use this special rule about moving the decimal when you're dividing, only when you're dividing by a 10 or 100 or 1,000, one of those numbers that's a 1 with zeros after it. So I'll use 3.6 again. 3.6 divided by 10, well, I can't move the decimal place one spot over to the right because I'm not multiplying, I'm dividing. It's the opposite. So what I'm doing is I'm moving the decimal one place to the left, and I end up with 0.36 as my answer, but I like putting a 0 there. Okay, so therefore 3.6 divided by 100, I need to move this 2 places to the left, and I need to stick a 0 there in order to do that. And I get 0.036 as my answer. Does that make sense? 3.6 divided by 100, 0.036. Yes, it does. And it'll work the same way for 1,000, 10,000. You have a cute little shortcut that you can do. And we got into dividing decimals. But that's it for this week for dividing decimals. I'm going to get right back into the multiplications. I'm going to do some multiplications that are a little smaller than that big one that I did earlier. But I'm going to try showing them both ways. These two strategies when you multiply decimals, where you can line up the numbers with the line, and you can kind of ignore the decimals and get an answer, and then put the decimal in the right place. That's one way. But another thing that you can do is just multiply the numbers but without the decimals. When I really think about it, it's like I'm saying the same thing, but I'm showing it 2 different ways. So let's do it both ways. And my first example for that is going to be, and I don't want great big giant numbers, not quite yet, 4.6 times, I won't write it like this, I'll write it like this, times 2.7. So there's more than one way of thinking our way through this problem. And one way, and I'll use this part of the chalkboard wall for it, is to say, well, this is going to be very similar to 46 times 27. Now I could just get the calculator and multiply that and write the number, but I think I want to show it as an old-fashioned multiplication that students who don't use decimals yet would be able to do. 46 times 27. There's a few steps to do here. 7 times 6 is 42, so I'm writing the 2 and I'm carrying the 4. And again, I didn't really leave myself enough room. It's always on the top that I forget to leave enough room. So I'm just going to write this a little higher. Okay, 7 times 6 is 42. I write the 2 and I'm carrying the 4. 7 times 4 is 28, plus the 4 I carried is 32. So I write the whole thing because I got to the end. Now, because I'm on this digit, and there's a number to the right of it, I have to put a 0. 2 times 6 is 12. I write the 2 and I carry the 1, and I'm putting it up here because I don't want to get it confused with that 4. 2 times 4 is 8, plus the 1 is 9, and I'm able to stop because I got to the end. Now I have to add these. 2 plus 0 is 2. 2 plus 2 is 4. Oh, messy. I'm writing quite low on my chalkboard wall. 3 plus 9 is 12, but I got to the end, so I can just write the whole 12. I have 1,242. That is the answer when you do 46 times 27. But we started with 4.6 times 2.7. And we have 2 digits in total to the right of the decimal in the numbers in my question. So I need 2 digits to the right of the decimal in my answer. 12.42 ends up being the answer. And then I ask myself, ballpark. 4.6 is almost 5. 2.7 is almost 3. 5 times 3 is 15. Not much higher. It's not... 15 makes sense when you see that your answer was 12.42. 12 is pretty close to 15. If I had thought my answer was 124.2, I'd think, oh, whoa, no, that's supposed to be close to 15. That's not close enough. If I thought my answer was 1,242, I'd say, well, there's obviously a problem here. That's not very close to 15. Even if I thought my answer was 1.242, I'd be thinking, I don't know, I'm a little suspicious. 1.242 is way too small. My answer's supposed to be kind of close to 15. And this ballparking thing is fun. It's kind of interesting to think about how close you get and why you get closer sometimes than other times. Both of these ones, when I decided that was close to a 5 and this was close to a 3, I was choosing numbers that were bigger than the decimals I had. 5 is bigger than 4.6 and 2.7. 3 is bigger than 2.7. So when I multiply the 5 and the 3, I should get an answer that's bigger than the right answer. And I got 15, which is bigger. Interesting. Both times they were bigger. The 15 I got is a little bit bigger. Huh. Interesting to think about how that works. But is this how we're always going to show it? It's a way of doing it. It works. But we can also do it 4.6 times 2.7. Show it like this. I'm not lining up the decimals because I have to because of addition and subtraction rules, because this is not an addition or a subtraction. The decimals happen to be lined up by coincidence because both numbers, the last digit I have has to be lined up above the last digit I have in the other number. And then I'm doing the same thing. It's really not going to be different at all. So it is really doing the same question the same way, but showing it slightly different. I have to get rid of this piece of chalk, get another one, but I'm still going to go through all these steps. I already know what it's going to look like. 7 times 6 is 42. I write the 2, I carry the 4. 7 times 4 is 28, plus the 4 I carried is 32. I can write all that down. This one I have to put a 0 here. 2 times 6 is 12. I write the 2 and I carry the 1. 2 times 4 is 8, plus the 1 I carried, not the 4, plus the 1 I carried is 9. I've got it. I'm able to add these numbers together to see what my answer is going to be. And then I count digits. 1, 2, 1, 2, 1, 2, put the decimal, 12.42, same answer. So doing it both ways is good because it makes us think about what we're doing and realize that what we're doing makes sense. And then we start to decide what we prefer to do when we want to show our steps in our multiplication. That was just the first one of these little samples to practice with. I have several more. And I'm going to keep on doing it the same way. Let's see where I'm at with the time. I think I might have time to do only 2 more. So let's get into it. Multiplying decimals, not so hard. A couple of new rules to remember, a couple of things that are slightly different, but mostly it's stuff we already knew because we already knew how to multiply non-decimals. Here's my next one. 14.23 times 1.8. I think this time I'm going to try the ballparking thing right away, and I'm going to put my answer to the ballpark over here. 14.23 is pretty close to 14. And 1.8 is pretty close to 2. And we can do 14 times 2 in our heads. We know 14 times 2 is 28. Even though it's not in the 12 by 12 multiplication tables, I think most students are pretty good at multiplying numbers by 2. So we have that. We know our answer should be kind of close to 28. But which way do we want to do it? I think I'm going to go right into this way. 14.23 times 1.8. Notice how I am not lining up the decimals. We have an example that really shows that off this time. I am lining up the last digits in the two numbers. The 8 and the 3 are lined up. And that doesn't make the decimals line up, and that's fine with the multiplication. But now when I do the next steps, I'm sort of ignoring those decimals. 8 times 3 is 24, so I'm putting the 4 and I'm carrying a 2. 8 times 2 is 16, plus the 2 I carried is 18, so I put the 8 and I carry a 1. 8 times 4 is 32, plus the 1 I carried is 33. I write the first 3 and I carry the other 3. 8 times 1 is 8, plus the 3 I carried is 11. I'm able to write that all down. Now I'm doing this 1, but there's a digit after it, so I need a 0. I'm going to end up adding, I'll just draw that line right away. 1 times 3 is 3. 1 times 2 is 2. 1 times 4 is 4. 1 times 1 is 1. Okay. Now, interesting how I didn't have to do any more carrying when I did this one, but it's because I'm multiplying by a 1. Small. So, and notice how I was ignoring these little numbers I wrote because of the carrying that I did when I multiplied the 8. You have to keep a few things organized in your head to be able to do this. Now we add the numbers. We still don't want to try and put a decimal in the answer. We don't have an answer. We have to add these numbers. 4 plus 0 is 4. A bit more chalk, please. 8 plus 3 is 11. Carrying for a different reason. I write a 1 and I carry a 1. 3 plus 2 is 5, plus the 1 I carried is 6. 1 plus 4 is 5. And 1 plus 1 is 2. We're nearly at our answer. We just have to count our digits that are to the right of our decimal places. There's 1, there's 2, there's 3 of them all together. 1, 2, 3. 25.614 is my answer. And I was expecting an answer that's pretty close to 28, so I have a lot of confidence in it. Now again, why did the ballpark end up being bigger than the answer? Well, the 14.23, I chose 14, which is actually smaller than 14.23. But for the 1.8, I chose 2, which is bigger. So it's a mixture of a smaller and a bigger, and I still got a bigger because the 2 is more bigger than the 1.8, then the 14 is smaller than the 14.23. You can think about that and sort of see the patterns, and it just makes you understand it more and feel more comfortable with it. One more example. I have time for one more example, but I have to do it quickly. Taking the same approach, 3.25 times 8.3. Don't need the clipboard anymore. Okay. So what am I going to do? I'm going to ballpark first. 3.25 is pretty close to 3. And 8.3 is pretty close to 8. So I'm going to pretend I have a 3 and an 8. 3 times 8 is 24. There's my answer from the ballpark. Notice that I chose 3, which is a little smaller, and I chose 8, which is also a little smaller. So I'm not going to be surprised if this is a little smaller than the answer I get. But I'm not going to worry about that now. 3.25 times 8.3, not trying to line up decimals, instead lining up these two numbers that are the last digits of my two numbers. 3 times 5 is 15, write the 5, carry the 1. 3 times 2 is 6, plus the 1 I carried is 7. 3 times 3 is 9. This one, watch out, I need to put a 0 here. 8 times 5 is 40, so I'm writing another 0 and I'm carrying a 4. 8 times 2 is 16, plus 4 is 20, so I'm writing another 0 and I'm carrying a 2. 8 times 3 is 24, plus 2 is 26. Woo! Let's add these. 5, 7, 9, 6, 2. How many digits to the right of my decimals? 1, 2, 3. So I need 1, 2, 3 digits to my right of my decimal. 26.975, which is a little bigger than my ballpark. And I was expecting to get an answer that was a little bit bigger, because I was thinking about how the ballparking worked. I'm starting to really like this ballparking. It's like an extra fun thing that kind of hangs around while you're doing multiplication of decimals and sort of helps you feel confident in the end. I like that a lot. But that is my last example for this lesson. I'm going to say goodbye from my beautiful assistant, from Mocha, who is very hungry upstairs, and I am going to rush up and feed her. And I look forward to the next lesson because this was a lot of fun. Bye-bye.